Hello. So this time we are finally ready to augment make map so that it generates the kanji input codes as well as the romaji input codes. Now currently, new make map will only generate codes for kana, and this is obviously incorrect. So what we want to do now is we want to use the kanji distribution module that we made in the last video and use that inside of the make map command implementation to include the kanji as well as the romaji codes here. And once we do that, we're going to have to update the test. And the test currently just has romaji here. And when it has kanji, it's the expected test output is going to be a lot larger. It's going to be about 1600 lines. 1500, I guess, maybe not 1600, because just the 40 times 40 formula doesn't really work since some codes are only one character long. And so we'll augment the test framework so that we can store the output in a separate file, and then we will update the test for make map as the last step, and hopefully we'll have time for all of that. So here we go. Let's look in kanji distribution.h and open up make map where we're going to be using it. And let's add an include for kanji distribution, right? Okay. So now we do know that we are going to want to we're going to want to get the kanji here. So we have a key mapping array. Let's see where that is actually. Where is that declared? Key mapping array. So it has a key mapping and then a okay. So yeah, this is just an unsorted array of codes of input codes to to what character they correspond to. So that seems fine. And we have get romaji codes here, right? And we also want to do this for kanji codes. So we're going to have let's just say get kanji codes here. All right. Static void get kanji codes. And I think we're going to have to return an error code, potentially. Mapping array. We pass the array in here, and that is the output where we put all the results. Kanji distribution kd equals. All right. Good. And what do we call first? We call kanji distribution auto pick cutoff. And later on, this command will support not automatic cutoff, but user specified cutoff kanji. For now, we'll do it automatically. Kanji distribution auto pick cutoff and pass kd. And then we do kanji distribution populate. And it is kd. Now, the way we use it, we don't have to call anything in between those two functions, right? We just call these two. I don't really like the way that I have to call two separate functions, but I guess that's okay. Because really, inside of these two functions, we can just call the populate function after that. But we'll just keep it for now. It's not worth changing. And so now we have kanji distribution populated, and we're going to have to also get, not only use that, but you need to also have so I just realized something actually, that this is going to be void because we're using auto cutoff for now, which does not return error code. Okay, now we want to get the free kanji keys. I guess that's in romaji.c. These are all the codes, two character codes that we don't need to use for romaji. And key index, free a singleton, mark use, get free kanji codes, short code array. All right, romaji, let's go to the header file, get free kanji codes. Okay, good. So we already included romaji. Now we can get the short code array, short code, call this free kanji codes. And this has to be freed, right? Destroy array free kanji codes. Okay. And that's fine. Now we call get free kanji codes. Kanji codes, right? And so now we have an array of 2-character strings. Now in kanji distribution, we do kind of have to find out free kanji codes in the process of populating here, because we need to know how many kanji to include in each line. But we do not leave that in the structure afterwards, and so we're going to have to call it separately, because all this structure will reveal to the caller is how many codes are there, but it will not give you the actual codes themselves. So now I want to know if these are sorted or not. Romaji dot h get free kanji codes. Get free kanji codes. Okay. It looks like it is sorted to an extent, right? It's not exactly sorted. So the first key is going to be the same. We're going to store the first key there, right? So it's gonna be sorted in this manner. Like if say we're gonna have a lot of codes, and then the first code that starts with B will be like BB, and then BC, and then BD, and then we'll have finally capital B here, right? So all of the ones that start with B are contiguous, and I think that's really all the sorting that we need. So we're going to go ahead and do for key 1, 1 equals 0. Actually, no, I don't think we need the key index. Kanji distribution.h. We don't need the key index, we just need the character, because we have this right here. So what we can do, we can sort through this. Yeah, I'm wondering, so these free kanji codes are going to be in that order I just explained. But these line stats, they're going to be each line is sorted according to the key index. So we have the key ch. So okay, so what we'll do is we will loop through the free kanji codes here. Okay, so let's see here, let's call it free code. Free code equals 0. Free code is less than free kanji codes dot count, and free code plus plus. All right. Now we have the char first key equals the first key of this free code is going to be free code dot element. No, free code is the index. It's going to be free kanji codes dot element free code. Okay, and that is That's going to be the first key, but we're also going to have to possibly make it lowercase. So I think that essentially means doing this. What is the bit? I think it's 32. 32 is the bit, which would be 20. Let me make sure that that's correct in order to turn an uppercase to a lowercase. So lowercase is 97 and uppercase A is 65, which is lower. So you actually want to turn on 32, not turn it off. 95, is that right? 97 and 65, difference is 32 indeed. Okay. Okay. Omoji o komoji ni kaeru. Okay. Turn uppercase into lowercase. Now we need to use that that function to convert the character code to the key index so that we can find it in the array. Because right, kanji distribution, no, where is it? Kanji distribution is going to have everything in key index order, which is kind of like the positional index of the keys. But we're looping through it in alphabetical order here. Or no, no, no. Are we? I think we're not. We're actually going to, excuse me, we are not, that's not correct. We're looping through in get free kanji keys in the key index order. We're converting this to a, where do we convert it? So kanji key count, key 1. Key 1 should be converted to a character at some point. Unused kanji keys, free unused kanji. Oh, this is get free kanji keys count. Get free kanji codes is going to loop in the positional index order, and it converts it to a character right here. Right? So it's in the right order actually. So we so free kanji codes.l, and now we want to say size. So we call this first key ch, first key character, and first key character, and this is a first key I, first key index, and it is it's the opposite of that map. It is char to key index. Oh, but this is static. Char to key index. Okay. I guess it's not static anymore. Romazi.h. No. Copy it first. Okay, copied. And here it is. If character is not found, character does not have an index, returns -1. Okay. So now we can do char to key index, char first key I equals char to key index first key ch. Right. All right. Okay, so we have the index and the character, and now we want to go through let's see. Now we need to find this index in the free kanji codes list. So I think we're going to have to do binary search because the free kanji, sorry, we have to find it in the kanji distribution list because the kanji distribution list lines are densely sorted. So if if a character is not used for any kanji keys, then it will not be in this list at all. So we have to do a binary search rather than just index it directly. So we have util.h for that. And this is resizing the window. Okay. We have bsearch. Now bsearch is a macro I use, and it's nice because you can just put the comparator in line here. It's just a regular expression that is used as a parameter. So bsearch e is set to the element, and so we'll call it struct line stats, I guess, and line stats. And the elements are stored in kd.linestats, and they have line stats and r as the count. And the comparator is so it should be int line stats dash oh wait, line stats is a pointer, so e is set to, okay, e is set as a pointer, right? Good. Line stats has a what? Where is it? Find kanji distribution. Line stats has a let's enr. Oh, actually, does it have? It has a key ch. So line stats dash key ch. We have to do a card to key index again, and this is already signed, so I don't have to cast it. So char to key index, and then minus we want, what do we actually want? We want the first key I, right? Now I think that is the right order. So compres is less than 0. So this should, if b is too large, if the thing we're looking for is bigger, then, so let's see, let's say we're too far in the array. So here's the array. Getting mixed up already. And this is the item that we want, and this is the thing we're checking to see if it's that item. All right. So if we return the thing the thing we're checking and subtract the thing we want, which is what we're doing here, then it's going to be positive, which means we'll say max equals mid, which means max equals this. Okay, yeah, that is what we want. Okay, bsearch. So we also want to make sure that first key I is -1. If it's -1, that means there's a bug. So we'll say cannot find key. What's a helpful error message? Cannot find key in char to index map. Okay. And searching. So here we want to see if line stats is null, then that's a bug too. Kanji distribution does not have expected line. Okay. And so now we've done that. Now we have to, so we have the line that we actually want from kanji from kanji distribution line stats. So we need to take a character there. Um, So we need to keep track of the index into that line, I guess, because we're looping through the free kanji codes, and we're not looping through the line stats elements. So we need to kind of keep track of, for each line stat, how many codes we've used. So maybe we can say size t codes consumed, and what is kanji key count? All right. Set that to 0, codes consumed. So we'll say size t next code index in the line. Okay. So we say next code I equals codes consumed, and we do first key I so this will be indexed, by the way, by the for simplicity's sake, it'll be indexed by with the sparse mapping. In other words, with the actual index of the key rather than the index into line stats. Codes consumed first key I plus plus. And so then we need to make sure that it's in range. Next code I is greater than or equal to line stats dash enr. Then we know that's a bug. All right. Not as many codes as expected in kanji distribution. All right. And I'm going to fix this error message later. Okay. So now we have a code. So I believe that we can say we can do, at this point we can add something to the key mapping array. So so we'll say grow array by m1. So now we can do m-l m-count -1, and first one is going to be so actually just want to copy free kanji codes, don't we? We just want to copy it from here. Free kanji codes, because free kanji codes already has the two character string which represents the code, I believe. H free kanji code shortcode array. Yes, shortcode array. And we're putting it in key mapping array, and key mapping has orig, right? So we want to say dot orig equals free kanji codes dot l free code, right? But we actually want to copy this, so we can do stir and copy, and oh, that didn't work. Okay, copy and set it to free kanji codes dot l. Okay, and stir and copy takes the size as the last argument. Okay, so this is size of m-l. Oh, but stir and copy always puts the, yeah, free kanji codes is not null terminated. So I think we want to actually copy 2 bytes always. So key mapping will be null terminated because it's initialized to 0 by grow array by. But we just saw that in so key mapping array is not null term. So key mapping the source. Wait. Key mapping array is a destination. So the destination is already null terminated because it's using grow array by, which initializes the new element to 0. But the source is the source, on the other hand, is free kanji codes, which is where? Short code array, which is not going to be null terminated. So what we'll do is we'll just do a memcopy instead. Memcopy takes the size as the last argument. Okay. The size is 2. Okay. And that means that m dash lm count. So now we have to set what the kanji characters that it converts it to, and that is going to be in. So actually, this is not right. Don't want to hard code 0 there. Count 1. Count 1. Yes, that's the last element in key mapping array. Key mapping. Origin conv. Okay. I think this can fit on one line now. And I was just interrupted for a second, but I'm back. Now we are going to specify the converting character, and that's going to be that's going to get what? That's going to get from kanji distribution dot next code dot. No, it's going to come from line stats, right? Line stats dash e next code I. But this has to be a kind of a copy. Dot C, right? Okay, now if I go to kanji distribution dot h, kanji entry should indeed be null terminated. Kanji db dot h, yes, it is. Nurushutang. That means null terminated. Now, this is going to be a stern copy, and copy destination first, and then source next. There we go. Does that fit? Oh, it fits on one line. Okay. And then the size of m dash l dash conversion. Okay. Now, does it build? No. Size h, okay. Size t. S size t is not defined. I guess I need to include standard int. But it's already included by kanji distribution. No, it's not. Maybe it's not. Standard int.h. And I'm probably including, okay, size t. Oh, romaji. Oh no, it's not here that the problem is. It's actually in romaji.h. This needs standard int. Okay, let's try. Okay, lots of errors. And romaji.h still has the problem. Where is standard s size t defined? Must have forgotten. Um, size t types.h sys/types.h. That seems right. Let's do sys types.h. No. Oh, too many .h's. Okay, that fixed something. Redefinition of struct because I included it twice. Romazi.h. Okay, so we're gonna have to use if defs here. If not defined, romazi h define. Okay, let's try that. Initialization makes integer from pointer without a cast. Okay, 19. Kanji codes -l. Okay. And then 43. .c should be a pointer. Oh yeah, that's true. Okay, because this is a reference to the canonical copy of the object in kanji database array. It doesn't have its own copy of the kanji entry. And then what's next? 19 again. Line 43. See another problem? No, same problem. Let's build. Let's see what happens. 19. Free kanji codes is actually a local stack allocated thing. Let's try again. Free kanji codes. Wait, what? Oh. Free kanji codes is a shortcode array which has an element shortcode array.l. Oh, because I need to get the first character in the code, not just any character. First key ch. Okay. Okay. Something failed. Does not have expected line. Does not have expected line. If it's null, no. Okay. kd.line stats char to key index minus first key I. Line stats like key ch. Okay. So some character is not being found. Let's see what character it is. First key ch. Xf printf. Oops. Let's just run one thread so we don't get confused about what's failing. 36 contributions not have expected line. Right. And it is what character? Oh, I didn't get it because it was written to the file. Okay. Don't want to use the testable stream. And it's colon. That's interesting. That's a shift. Oh, I see. Because we also handle not just making lowercase letters into not just turning uppercase and lowercase. We also have to handle turning colon into a semicolon and less than into a comma. So yeah, how are we going to do that? So we might do this already somewhere. There's like an unshift, maybe some kind of an unshift thing. Char to key index map. Char count. So what we could do is we could take the first key C8. No. I was thinking convert it to an index first. I guess we could do that. So convert first key ch into first key I, the index, right? So here, okay, and now, okay, shift 文字をアンシフトに変える. For example, that just says turn a shifted character into an unshifted one. G. For example, colon becomes semicolon. That becomes that. Okay. Okay, let's format that nicely. So first key I modulo equals kanji, what's it called? Kanji key count. And then first key ch becomes key index to char map first key I. Okay. So we're basically using this map, this array to turn the shifted key into the unshifted key. Probably have to put that into a reusable function later. Okay, good. It looked like that worked. And how many lines were different? 1,251, which sounds a lot like the number of characters we expected, number of kanji characters we expected to have. So if I run new sort last rank contained, it should show the same value, 1250. So I remember there was a header line in that diff, so that explains why it's one less than 1251 and not exactly 1251. Okay. So okay. I'm not sure what I want to do about this line. I guess I'm going to delete it now. And I want to make sure these codes really make sense. So do they actually look like they put all the characters with the same radical in the same place or contiguously in this code? And kind of looks like they did, but I'm not totally sure. So maybe we'll just do this. Like let's run this again. What we'll do is we'll run new source. We'll run last rank contained and make sure that that's not enough room actually. Let's close this editor. Okay. Make sure that the radical for the characters here matches what we see here. Or actually, we don't even have to check the radical. We can just like copy this character and make sure it appears in the right spot. Okay, so this appears here with first character slash, and this appears as a question mark in the code, which means a slash with a shift. So that's fine. And so here is also the same character in the same area. Then if I jump to here, the first one in this line, it's here, and that's correct. Okay, and maybe we can go to the very first line and make sure that's right. So hito, one is here, okay, and this, which means death, this should be down here. Okay. And let's just pick some character in the middle, like kokoro, heart, has a Q as a first character, and here it has Q as well. So that looks very good. I don't think there's any problem there. So now we actually have to update the test. And like I said, I want to make the test allow me to put the expected output in a file, like rather than as a constant, like as a C constant, which is a bit cumbersome to handle. And I will do that, I guess, this afternoon after work. Right now, I need to handle some other stuff. And so, yeah, I think that I can probably end the video at this point. So thank you for watching, and we will write the test in the next video.